Okay, so, whoops, sorry. Today we're going to talk about trapezoids and kites. Trapezoids and kites. So if we think about it, the first lesson we did the parallelograms, two pairs of parallel sides, and we went through all the characteristics of the parallelogram. The trapezoid has only one pair of parallel sides. We're going to see that we're going to have to prove that the other two sides are not parallel. So we kind of know what a trapezoid looks like. This is a general shape. The parallel sides, they're known as the bases. Because you recall from your earlier geometry lessons, the area was equal to 1/2 the height times the sum of the bases. You recall that once again, the area of a trapezoid is 1/2 the height times the area of the bases. And you recall maybe you did that, you found the height here, and you found the height here, and you're like, oh, two triangles and a rectangle. That's how you found the area. That's not important now. So the two sides are bases. The non-parallel sides are known as the legs. Okay. And so this is in general any trapezoid. We have two trapezoids we're even more interested. The first type of special trapezoid is the isosceles trapezoid. Isosceles trapezoid. And some of you might say, okay, I kind of have an idea what this is. What do you think? Well, it's a trapezoid, only one pair of parallel sides, but the legs are parallel. It's a trapezoid, and the legs are congruent. Okay, so, and it looks something like this. You say the legs are congruent, parallel. What else can we conclude? You might say, you say, okay, the base angles are congruent. Base angles are also congruent, just like an isosceles triangle. It all follows through. The other interesting thing is what we can prove is, let me get another colored pen. You could prove that in an isosceles trapezoid, you can just on your own, the diagonals are congruent. The diagonals are congruent. You can prove this on your own. Or it might be an exercise in the end of the unit stuff. Let's see, and then also from the also you can look at the mid segment. That's another interesting thing. Reviewing that last unit from mid segments. Let's take another pen. How about blue? What do you think? What do you think the mid segment? So this is the midpoint. And what do you think the mid segment? The mid segment, it's also, what do you think? Well, actually, this is kind of interesting. This actually is parallel to the parallel to the other bases. And I want you to think about it on your own. What the relation? How do we find the length of the mid segment? What do you think? You can pause it, you can think about it. It actually turns out it's the average of the bases. It's actually 1/2 the length of the sum of the bases. The mid segment in a trapezoid, an isosceles trapezoid, is the average of the bases. Nice. Okay. The next type of trapezoid we're interested in looking at is the right trapezoid. Okay, so I totally forgot to draw you a picture of the right trapezoid. So, first of all, you should be using a ruler. And so you know what? I should be using a ruler. And so the idea is you have your two parallel sides. And the idea is that one of the legs is perpendicular. One of the legs is perpendicular this is a parallel, 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 parallel. One of the legs is perpendicular to the bases, but not both of them. And you can prove a couple of things. You can prove the diagonals are not congruent to each other. You can prove that the two legs are not congruent to each other. And both of these, the ideas, you start off with the assumption that they are, and you would arrive at basically in both cases, you would arrive at the idea that we no longer have a trapezoid. And so, but once again, only one leg is perpendicular to the bases. Once again, the diagonals are not congruent, and the legs are not congruent. Once again, a right trapezoid. Good. Sorry about that. What I want to talk about just really quickly is, oops, sorry, blue, that's the trapezoid. And we'll be talking about proving it. So first at home, we're just going to be doing, once again, the typical basic trapezoids, homework involving trapezoids. Good. Copy, I'm erasing. The next one we want to talk about is a parallelogram and a quadrilateral that has no parallel sides. And the easiest one for us to look at is something called a kite. Like the kites you make when you're little kids. They look something like this. Okay, and you notice a couple of things. You notice, first of all, this is known as a kite. There's no sides are parallel. And I mean, obviously you can make another shape. I guess not parallel, not parallel, not parallel, not parallel. So here's another shape this is a shape, I think they call it a trapezium in America. So I'm not sure what they call it in England. Anyway, but we're gonna look at a special kind of kite. So let's say, no sides are parallel, but you're gonna specifically notice that the consecutive sides are congruent. So this is congruent to this, and this side is congruent to this side. The other thing you might notice is that when you're a little kid making those kites, you take the two pieces of like balsa wood and you make the diagonals perpendicular. And so this is the idea of your kite. And that's basically it. You can see all the angles are congruent, which specific angles are congruent. They don't necessarily bisect each other. It's clear that the big one is not, but this one is bisected. So one of them bisects the other, but that's not important. You'll see that. And then basically it's just a lot of like triangle proofs, or maybe just a lot of Pythagoras theorem. And that's basically it. Is there anything you want to say about the kite? Nope. We'll talk more about that with the proofs. So work on the exercises in the back of the unit. Good. Let me shut this off. Where's the stop button? Stop.